Hello, dear students. Today we have proposition 8. It's going to be called, for us, we're going to use the shorthand, side, side, side. Remember how we had side, angle, side? This is going to be side, side, side. Here's how the enunciation goes. If there be two triangles, such that two sides are equal to two sides, and the base equal to the base, that angle which those two sides contain, those two equal sides contain, is going to be equal. Those two angles are going to be equal to each other. Okay, so here's the given. Two triangles such that two sides are equal to two sides respectively, and the base equal to the base. Thus, it is required to show that this angle equals this angle. Notice how I say that in the particular, by the way. We said the universal, we go down to the drawing, the imagination. The imagination helps us, and then at the end of the proposition, the intellect is going to say, and that's true in any case, because these are intelligibles, remember? Great. So let's do in the particular right now. Let's start. Let's put this triangle on this triangle, such that this point is put on that point, this line is lined up with that line, and we know that this point will fall on that point because they're equal. Remember how we did that little reductio in proposition 4, if it fell longer, it fell shorter. Okay, we're not going to do that all over again. We know that there's going to be, the points are going to coincide perfectly. Okay, so now we have this triangle on top of this triangle. I say to you that these two lines will coincide with these two lines. By the way, that's how we're going to prove equality here. We're going to show coincidence. Okay, so I say that they coincide. For if not, you would have something like this, that they wouldn't coincide. This line not coinciding with this one, and this line not coinciding with this one, something like this. However you want to draw it, the point is that triangle would meet at a different point, not at that point when you put it over. This is a little reduction, yeah? So now we have a case contrary to what we showed in proposition 7. Remember, proposition 7 showed to us that there cannot be set up on one straight line two straight lines meeting at a point and two other straight lines meeting at a different point, such that those coming from the same points are equal. That cannot happen. You can review Prop 7. It's always good to review. So because we showed that that cannot happen, we know that that cannot happen, that they would fall at a different point, they must fall on this point. Great. No, I'm not getting this up. So you'd have them falling right here. Therefore, you would have coincidence. Things which coincide, areas which coincide, figures which coincide are equal in area. So these three lines would be coinciding. If this line coincides with this line, etc., then the angles are going to coincide, obviously. If the angles coincide, the angles are equal. Quod erat demonstrandum. That is to say, we have shown that if there be two triangles with two sides equal to two sides respectively, and the base equal to the base, necessarily the angles which those two equal sides contain will be equal. Then you can say, well, you see obviously the triangle is equal to the triangle as well. The other angles are equal to the other angles. Quod erat demonstrandum, side, side, side. Thank you.